Hi, the 3.3, the Pearson's chi-square statistic. And so this is a different test from the section 3.2. And it can be shown that the following chi-square statistic approximately follows the chi-square n minus q minus 1 under the null hypothesis that the model is correct. And what's the chi-square statistic? It looks x, but the capital of chi is the same as x. So chi-square is defined by summation of the Ri superscript p. So actually this should be square. This entire quantity is square. And this is equal to actually defined by the summation of this yi minus ni pi hat over ni times pi hat 1 minus pi hat. So basically, okay, so pi hat. So this has the q plus 1 parameters. Because fitted value, the pi hat, is explained by the q predictors plus intercept. So we have q plus 1 parameters. And also, the sample proportion, or maybe the count, out of some fixed number of trials. So this is approximately the normally distributed. So if we subtract NIPI hat, this is actually the expectation of yi. And if we divide this by NIPI hat times 1 minus pi hat, this is actually, if we take square root, the standard error of yi. Okay, so this is expectation, and this is the standard error of yi. Then this is the standardized random variable, and the yi is approximately normal. So this entire quantity follows approximately normal 0,1. So since this RIP is approximately normal 0,1, if we take this square, then take summation, that becomes chi-square distribution. Okay, so distribution. So the definition of chi-square distribution is summation of the independent standard normal square. So that's why this holds. And the degrees of freedom is actually not n, but n minus q minus 1. And remember that, for example, the summation of the x bar square I is equal to 1 to 2. So this follows chi-square 1. So you can show that. So we need some variance condition, but this is true. And if we have more terms, the n terms, it becomes more complicated linear algebra. But anyway, finally, we can prove that chi-square follows this distribution, chi-square n minus q minus 1. So here, ni, so this textbook uses ni and mi. Both are the number of trials for the ice observation. So in our case, everything is 6. And RIP is called the Pearson residual. So the chi-square statistic is the sum of squared Pearson residuals. And how to calculate this? Actually, I don't know any function, and the textbook doesn't discuss it either. So just calculate everything from scratch. So fitted probabilities are obtained by fitted value of logistic regression object, binomial regression object. And n is 6. N sub I is 6 for all observations, all 23 observations. So repeat 6, 23 times. Then actual observations, actual observed, the numbers are given by this damage, the variable. So this is y ranges from 0 to 6. So this is 23 dimensional the vector. Then chi-square is calculated by this formula. So chi-square statistic becomes 28.06. And if we want to calculate p-value, so this is p-value. So p-value is chi-square, then degrees of freedom is 21. So remember that n is 23, and yeah, n is 23, and the p number of parameters, so the 2. So 21. 23 minus 2 is 21. And the upper tail probability, so we put the lower is equal to false, then we get 0.138. So no strong evidence to reject null hypothesis. So this is at least consistent with the previous result in the section 3.2. But again, so this uses different approximation. So this uses normal approximation of yi. So the number is not exactly the same. P-value is not exactly the same as the section 3.2.